and unit number 1, that is discrete mathematics, that is logic and predicates. Just let's start the questions. So I will take the attendance if you are active enough. Same rule follow. Okay, I will check who is active throughout the who is going to active throughout the lecture. Then after the lecture, I will mark present to that person. If you feel that you will not be active enough during the lectures, you can leave the class right now. Okay. All right. Uh, Start with the. So first, your task is to solve question number 5, 6. Sorry, not 6. Question number 5, question number 9 and 10. 5, 9, 10. Solve this and write down your answer on chat box. Just option. All of you have to write a chat. Okay. I want the answer from all of you. After completion of the lecture, I will check who is the active person and I will mark present to that person only. Today we will solve planar non-planar graphs, that is unit number 6 of graph theory, and unit number 1, that is logic and predicates. Logic and predicates. Also there is some information regarding your quiz. I will tell you also in the WhatsApp group as well. So coming Sunday, today is the Friday, day after tomorrow is your quiz of unit number 6, planar and non-planar graph. Okay, the same rule will follow. Okay, like the last quiz, there will be 20 marks quiz of planar non-planar graph, 10 questions, 2 marks each. Okay, I will tell you the time later. The response from Krishna, Hamnet, Nahum, Theodros, Arafat, Ingridward, David, Matthews, Gloria, Sekhar. Okay. I'm waiting for your answer. All right. So moving forward, we will answer. First of all, question number five. I think everyone's written this 5A. Yes, 5A is correct. Krishna 5 should be A. So uh, P implies Q means if P then Q. Okay. P implies Q denotes if P then Q. 5A. Those who have put A is the correct answer. No problem. Number 9. Which of the following graph is a planar graph? A planar graph, as I know, question number B, option B is the Kuratowski's second graph. Option B is Kuratowski's second graph, that is K33, complete bipartite. And number C is Kuratowski's first graph. So these two graphs are always non-planar. Also, Peterson graph is always non-planar. We know that. Okay. So finally, which one is left? Left one is K3, and we know that K3 is a triangle, and it's always a planar graph with having two regions. So option A, 9, option A is correct. And 10, question number 10, we will have planar graph contains 8 vertices, 9 edges. So we'll follow this rule. N minus E plus F equals to 2. According to the rule, N equals to 9, E equals to N equals to 8, E equals to 9. So F equals to 3. So option B is correct. 9B, 10B. All right. So 5A, 9A, 10B. Those who have put this answer, this is correct answer. Okay. So moving forward for next question. Okay. So you have to write this definition of a proposition. Write down the definition of a proposition on chat box, and you have to write. All of you have to write the stuff in your one sentence. Just explain your thoughts, nothing else. Okay. Write the correct thoughts. What is proposition? Proposition means another word. It is true. It is a statement. So proposition is a statement. So proposition, uh, another notation of proposition is statement. So you can write the definition of statement as well. So what is a proposition? Proposition is also known as a statement. Okay. So just another nomenclature of statement is proposition. Okay. So write down the definition of a statement in single sentence. All of you write it up on chat box with what is the statement and what of proposition. So what is a proposition or statement? So answer uh, given from Gloria, Hamnat, Eba, Nahum, Theodros, Ingridwork, David, Matthews, and Krishna. So the thing is that a proposition, as you know, it's a sentence. Okay. Those who have written that is a statement, that is wrong. Don't write a statement. It's a sentence which is either which can be either true or false, but not both at a time. Okay, either can be true or false. It's having some value. Either can be true or false, but not both at a time. This is known as a statement of proposition. Number two. Now your task is to question number two. Draw the table of biconditional statement. Table means truth table. So it is not possible to write the truth table in chat box. So I'm uh, making your task slightly easier. So as you know, biconditional statement, I'm writing this first input, that is T T T F F T F F. Okay. So what you need to do, you need to write the output about biconditional statement on chat box. So write down the output only on chat box. Okay. And in exam, you have to write the whole uh, truth table of biconditional statements. Okay. So write down the output of biconditional statement on chat box, all of you. Only output. Gloria, write. You can write in a row also. Just in a single sentence, you can write it. Like whatever it is, T T T T, whatever that is. Correct. Biconditional statement. Ingirwar, correct yourself. Ingirwar, correct your answer. Biconditional statement. All right. So in any case, the biconditional statement is truth table. The output is TFFT. TFFT is the output. Okay. So those who have written TFFT is correct. No problem. Okay. And moving forward, so the next question. Next question is number 7. Next question is number 7. Which are the Kuratowski's two graphs? Is that planar? So you have to write down the Kuratowski's graph, and are they, is that means this should be are they planar and kind of stuff. So you have to write a planar or not. Okay. Kuratowski's two graph. Write down on chat box Kuratowski's two graph. What is the notation of Kuratowski's two graph, and are they planar or not? All of you write down the stuff. David, question number 4. Uh, we haven't started yet. Okay, David. It should be in the last unit, unit number 3. Okay, so after completion of unit number 6 is a part of Boolean algebra. Okay, David. So that's why it's we skip that stuff. So today we will solve only a planar, non-planar graph and logic and predicates. Only these two units. All right. So many of you have written K33 and K5 is the answer, and both are non-perfect. So moving forward to next question. So define planar graph. Okay. Before leaving, go for number 7, number 8. Go for number 8. Verify Euler's formula for a complete graph with 4 vertices. So what you need to do? You need to write down just a verification only. Verification step, nothing else. Just a verification step. What is N, what is E, what is F? Just write down the verification step, and I will understand. On chat box, all of you, you can write it on chat box. Number 8, question number 8. Moving forward. Mathus, you have to write what is N, what is E, and what is F in this particular question. You have to mention what is the value of N, E, and F. Then verify. So just write down the what is N, what is M, and what is N, E, and F. That is just 2 plus M, min. See, David, nothing you need to do. Just you have to write down this. What is number of vertices for a complete graph with 4 vertices? 4 vertices given. That means n equals to 4. So n equals to 4 and complete graph. That means you can figure out what is number of edges, right? So e equals to should be what is the value of e. Then calculate what is the number of faces f. Don't just write in theoretical manner. Write in numerical manner. Yes, Angira box. That is correct. Okay, so you have to write in a numerical manner. Yes. All right, perfect. So n equals to 4, e equals to 6, and f equals to 4. The correct answer. And yes, n minus e plus f equals to 2 is satisfied. That means we verified Euler's formula. Next, go for number 9. All of you go for number 9. Define a planar graph. Okay, you have to define planar graph in a single line, single sentence. Okay, so try to write the correct definition. I want the correct definition from all of you. Okay, in a single sentence, define planar graph. All right, so Gloria, Salamovic, Nahum, Theodros, Arafat, Eba, Hamnath, and Matthews. Okay, so let's check the answer first. So David says planar graph is a graph that can be embedded in a plane. So it cannot be embedded in any plane, right, David? If I can embed in a plane where we can make the edge crossover, that is not a planar graph, right? So you have to write that it's a connected graph. In other words, it's connected graph without any edge crossover. Business is Drawn without any H crossover. Planned. Matthew's planar graph with no H cross. So there are two things you have to write. First, you mention it can be embedded in a plane and embedded in a plane without any edge crossover. These two words you have to mention: without any edge crossover, or embedded in a plane, like or you can say we can redraw the graph. Okay, we can redraw the graph in a plane without any edge crossover. These two definitions is possible. Okay, either you can say it can be embedded in a plane without any edge crossover, or you can write it can be redrawn in a plane without any edge crossover. Then you can say this graph is a planar graph. Okay, otherwise all answers are slightly partially correct. Okay, so these are the questions of 17-18 winter, and this is a one marks question. So I will follow only 1 marks question today. So let's proceed for the next year question paper. 17-18 winter. 17-18 winter. Before I think it's maximum is going to be same here. Yeah. So leave it 17-18 winter. 18-19 question paper. Let's start. So 18-19. Start with this question. Number 1. Go for number 1. Next, number 5, number 6, also number 9. Yes, so there are 4 MCQ. You can solve it. So start with 1, 5, 6 first. 1, 5, 6. I think it is visible. All of you start 1, 5, 6. Write down your answer on your chat box. Just to write down the option which one is correct. 1, 5, 6. 1, 5, 6. After that, we'll move on to the next question. Let's start. All of you. So till now, the active students are okay. Zoom. David, what you can do? You can click on the screen. David, you can click on screen. Anyone, if you want to zoom, there is one way. Just click on the screen. Okay, click 2 times or 1 time on the screen. You can easily zoom it up, or you can magnify the screen using your finger if you are using mobile. Okay, because I want to show 3 questions simultaneously. That's why I cannot zoom in. Okay. So Arafat, David, Eba, Ingitawak, Gloria, Hamnat, Krishna, Matthews, Nahum, Selamavit, Sekhat, Theodros. They are all who are present right now. They are active. Good, very good. Carry on. All right, I think you've got response from many of you. So the first one, if I zoom in, the first one is actually uh, number of odd degree vertices even P is true. A cycle cannot be a tree. Q is also true. So P and Q both are true. That means C is correct. And moving forward to next one, number five connected graph with six vertices n equals to 6. So 8 equals E equals to 8. So faces, number of faces you have to figure out. So n minus E plus F equals to 2. As you know, this formula will work here. So 6, that is going to be 4, I think. Okay. So number D will be correct. F will be 4. All right. And number 6, P is 15 is the square of 7, or minus 31 is a negative. So this is a statement. If 15 is the square of 7, or negative 31 is negative. That means what? That means this is a combination. This is a disjunction kind of stuff. So you may say P1 or P2 kind of stuff. So once I want to figure out the negation of this statement. So negation of this statement, that suppose we have P1 or P2, and we want to figure out the negation of this. Okay. So that is what we will use. That is known as uh, De Morgan's law. So by De Morgan's law, we can say that this is not P and not Q, not P1 and not P2. All right. So that means what? We have not P1 and not P2. So we have to focus on and. How many ands are there? A and B are and. So D and C by default cancel. So we will go for not P1. Not P1 means P is not a square. P for 15 is not a square. It's perfect. And negative 31 is not negative. So this 2 is correct. So B is correct here. So option B is correct. Number 6. All right. So those who have put option B, option number 6 is correct. All right. Moving forward, next question, number 9. Okay. Complete this stuff. Number 9 and 10. Number 9 and number 10. Go for number 9 and number 10 both. Write down the options on chat box. Number 9 and 10. All right, I got a response from all of you. So think number nine. So many of you has written number nine, C D mixer. So the thing is that options. So which one is a non-planar? First of all, we can make this as embed this graph by making this edge from outside and make this graph from embedding by doing this stuff, also doing this stuff. Okay, so this embedding is possible A and B, but number C, if I look at number C is a complete graph K 7 is a complete graph K7. So K7 is a complete graph, and we know that every complete graph above K5, that is K5, K6, everything, every complete graph above K5 are always non-planar. That means this graph is your answer. So number C is correct. Number C is a non-planar graph. Okay. And number 10, Huyson's truth table is for conditional statement. So it should be TFTT. So TFTT means number C. Number C is correct. Those who have written 10th number C is correct. TFTT for conditional and TFFFT for biconditional. Okay. So conditional means TFTT. Go for number C. Okay. So moving forward, so next question. So the next question, I think this all are actually from unit one. So unit one, you can solve this one. Logical equivalence. So last one question only. Number 7. Write down your answer in chat box in sentence. Okay, don't write any mathematical expression. Just write in a sentence. What is the definition of how you can define logical equivalence? All of you write down on chat box. Logical equivalence. How you can define logical equivalence? Write down on chat box. Logical equivalence. All right, so many of you put their responses. So um, it works if they have same truth table for all possible conditions. They have means you have to write this to they means it should be compound statement. So one I'm saying it's a logical equivalence. So logical equivalence we can decide with in between two compound statement. Okay, so two compound statements are logical equivalents to each other. The basic concept, the basic definition should be logical equivalence are two compound statements are logical equivalents to each other uh, uh, if P by implication Q are tautology, or you may say uh, their outputs are equal. Their output of the truth tables are equal. So that is the Theodorus. Yes, Theodorus answer is correct. Theodorus, it should be P by implication Q, not P implication Q. Okay. And many of you have written some answers, partially correct, and Gloria written that two statements of forms are logical equivalent if they have identical truth table. Uh, Not exactly identical truth table. You can say identical output. Okay, Gloria, identical output, because truth table may not be same, but the output will be equal. Okay, identical output. All right. Uh, okay. So moving forward, so that's all about this question paper. Next, moving to winter 1819. Winter 1819. Question number 1. 5, 6, and yes, 1, 5, 6. So first solve 1 and 5. Solve 1 and 5 first, and then 6. All of you solve 1 and 5 and write down the answer on chat box. Matthews, two propositions P and Q are said to be logical equivalent if and only if P by implication Q is a tautology. Yeah, P by implication Q, not P implication Q. What you have written that P implication Q, you have to write P by implication Q. Otherwise, correct. Okay. All right. So this question, in question number one, number of odd degree vertices is even. Sum of the all. So both are actually true. So P and both P and Q are true. So question number one C is correct. Number five, connected graph with 6 vertices, 7 edges. So n minus. So it's going to be number of faces should be 3. So C again. 5 is also C. 1C, 5C. Yes, correct. And number 6. Number 6. Go for it. Again, it's a question of De Morgan's law. Number 6, De Morgan's law. Use De Morgan's law. All right, question number 6 again. Yes, uh, 2 is even. That is the first statement of it should be the negation of this is 2 is not an even. So here is something I feel this is something like wrong statement. 2 is odd is not exactly correct, but it should be 2 is not even. But still 2 is odd. There is no option in this case, so option B is correct here. 2 is not even, and because by De Morgan's law, okay, 2 is not even and negative 3 is not negative. Okay, so moving forward, so some questions over here. So in this case, we have already done. Now you have to write what is conjunction. Now you have to write what is conjunction. Write on the chat box what is conjunction. Write on the chat box what is conjunction in without using any mathematical terms. Okay, try to write without using mathematical term. What should be the definition of conjunction in one sentence? All of you participate and write. Okay, Theodorus says that conjunction is like a coordinator between two the same thing of or sentence. Uh, I didn't find it's not making sense any Theodorus. Nouns is a statement formed by adding two statements. Uh, Muhammad Hasnat says that uh, two statement both should be true or false. Not like that exactly. Conjunction means that it's an operator. The best things to write is it's an operator. Okay, like the best thing you can write is there are two compound statements or two statements P and Q, P and Q, and if I use an operator like upper cap, and that operator is known as the conjunction. The role of conjunction is to making like P and Q. Okay, we can say that the P and Q is going to be the output of the statements. Okay, it's a compound statements P and Q. Okay, so that means what you have to write in examination. You have to write down the definition and then go for the truth table. You have to mention the truth table as well. Okay, so that is what you need to do in the examination. That is known as conjunction. Okay, now moving forward for the next question. What is contingency? Go for contingency. Contingency is some, if you remember, contingency is a part of the types of compound statements. That means it's either tautology, either a contradiction or contingency. Okay. So write down the definition. What is a contingency? Which kind of compound statement is known as contingency? Just write it down. Okay, so yes, so it's a compound statement which is neither tautology and contradict nor contradiction. It's a correct Arafat. You can go for this definition. Matthew says a truth value contains both true and false. Truth value, it's wrong. Go for output values. Okay, so output values contains both true and false at a time. Uh, Davids's proposition that is neither tautology is correct. Solomon is if truth table both contains not truth table Salamovit, it should be output values. Okay, of the truth table. Eva says it is neither tautology nor a contradiction, and the truth table must. Yeah, it's correct. Hamner says either true under every possible variations, tautologies, nor yes, that's correct. Neither true nor neither tautology nor contradictions. Okay, very good. Okay, moving forward. So next question paper. I think this is last question paper. 1920 winter. So 1920 winter. Number two. Go for number two, three. So number two and three. Go for number two and three first. Number two and three first. Write down answer on chat box. Be careful while you are writing answer. Number two and three. All right, so many of you have put in their response. So that is so question number two. We have to figure out the non-planar graph with the minimum possible number of edges and minimum possible number of edges only. Okay, don't go for number of vertices. So obviously, uh, while we are looking for minimum possible number of edges, that is, I know that K33 is the graph which is having the non-planar graph with minimum possible number of edges. That means how many edges will be there in K33? 9 edges. 9 edges means with 6 vertices. So 9 edges, 6 vertices, K33 is going to be the answer, and B is going to be the correct answer. Okay. Next, number three. Which of the following is not planar? Which of the following is not planar? So first of all, G1 is planar. How can I say G1 is planar or not? Just remove this edge or redraw this edge from here to here. Okay, and redraw this edge. Suppose, or no, just a minute. And withdrawing other two edges is not possible. Till now, it's not possible. It's apparently looking like. So this thing is planar. G2 is planar, no problem, because it's already embedded. Uh, yes, we have to rearrange. We will try G1, but till now it's not possible looking like apparently. G3, G3 in case of G3, we can redraw this graph edge from outside, and we can make it planar. So G3 is also planar. And G4. So G4, what we can do, we can make it from here to here. All right. Now we can uh, join this edge from here to here, or you may say, okay, color this color, different color. So we can redraw this edge from outside, and this is the redraw is possible. So this G5, G4 is also planar. So all G1, G2, G3, G4 all are planar. So G1 is non-planar. You cannot redraw G1 in a plane. So you cannot embed G1. Embedding is not possible in case of G1 in a plane. So that's why G1 is non-planar. Option A is correct. All right. Which one is non-planar? G1 is non-planar. Yes. Go forward for number five. Next question number 5, 7, 8, 9. Number 5, 7, 8, 9. Write down your answer on chat box. 5, 7, 8, and 9. Go for it and write it up. All right. So many of you have to put your answer. So first one, number five. Number five is the simple connected graph. So 13 vertices and 19 edges in the number of faces. So simple n minus e plus f. So it's going to be 8. Number B is correct. So number 5, B is 5B is correct. Those who have put a B is the correct answer. Number 7, the disjunction even if one of the statement is false, the whole disjunction still uh, one of the statement is false. Disjunction means or one of the statement is false. One of the statement is false, the whole disjunction still. Okay. See, one of the statement is false means the other one might be true or might be false. Okay, if it is true, then by disjunction is going to be true, your answer will be true, and if it is false, then answer is false. So we can go for option C. Okay, so neither can be true or can be false, both. Okay, then number 8. All right, number 8. Number 8 is already we have done. That's A, option A. If P, then Q. Which of the following is logically equivalent? Number 9. Number 9 is actually De Morgan's law using quantifier. So De Morgan's law using quantifier is something like go for first this one. All right. Negation of for all x px should be equals to equivalent to there exists x negation of px. So 1 is equivalent to 4. 1 and 4 is going to be equivalent to each other. That means option B. So 9, option B is correct. So just take care about 7. 7 is option C. Okay. So 7 is option C. And apart from that, everything as per your answer. Okay. Negated means it's something like make it ineffective. Okay. So nullify kind of stuff. That's why it's negated in number 7. Okay, because we cannot say anything, okay, about the disjunction. Okay, so go for go for go for our next question. Next questions, already you have solved disjunction, no problem. Disjunction only you now you write down this definition. Tautology, so this remain. So go for tautology and wheel graph. There's two definition you have to write on chat box. Write down the definition of wheel graph and write down the definition of tautology. This is the last question, student. So go for it, write it down. I'll give you 5 minutes of time and later on I will check it. Go for wheel graph and tautology. Write down the definition, only definition of wheel graph and tautology. All right. So many of you responded. So tautology is a compound statement that produces truth. So Nahum said. So the thing is that tautology, the basic concept of tautology is something like you have some compound statement, um, and that is always true. Okay, so any compound statement which is always true, that's known as tautology. Simple logic in language. Okay, so that in other case you can write it the output of the truth table of a tautology is always true. Okay, so Arafat, right? The compound statement is always true no matter what's the true value is given. Yes, correct. So you can I can refer to the definition what is written by Arafat for tautology. You can check it. That is a perfect statement. Okay, with zero error. Uh, and wheel graph. Wheel graph. Matthew says wheel graph is a cycle in which single vertex is connected with every vertex. Wheel graph is a cycle, not as a exactly cycle. Nouns of wheel graph formed by connecting a single universal vertex to all vertices of a cycle. Yes, that is you can write now like wheel graph formed by connecting. So connecting, Nahum said wheel graph formed by connecting a single universal vertex to all other vertices, um, constructing a cycle. Constructing cycle with each and every vertex. So best writing is wheel graph is a graph constructing formed by connecting a single universal vertex to other vertex, other vertices, um, forming a cycle to each and every vertex, forming a cycle to each and every vertices. All right. So Arafat says like our attendance, no matter what's the true value is there, our the attendance is always true. No, Arafat, your attendance is not always true. It depends on conditions. Okay. So if conditions, if you fall apart under then your attendance is true. Otherwise, it's false. Okay. So it's not always true. Even if I talk about the attendance table, you can check the attendance table also. Let's check the attendance table. Okay. It's not a tautology. It's a contingency. Your attendance table is a contingency. Look at this. 111 01 11. So in any case, it's a contingency. So I can give you some task also. Okay, okay. So what I don't know what it mean for. So like our attendance, no matter what's true value is there, out attendance. Out attendance means output attendance. Always will. Yes. Students attending a class or not? No, that's not true. You will never get attendance. If we attend the class, then only you will get attendance. Okay. So I will for example for today, I think all of you were actually attentive. That's why I will mark all of you actually present. Otherwise, so I'm giving you some name today. Let's take the attendance. So it's sorry, C batch.
Yes, sir.
Just a minute. Tamiru. Tamiru, I think is absent, and no, no activity from Tamiru. Siraviju is present,
Yes, sir.
and is active today. No problem. So he's present. Salamavit is active today.
Yes, sir.
Yes, he is present. Johannes, I think Johannes is not active. Is inactive today. Yes, yes. Johannes is inactive today, and he is also Absent. Theodros. Theodros is there.
Yes, sir.
Theodros is active and he is present, so is active. I will mark him present. Matthews present, was active. Zacharias not active, absent. Krishna active, present. Angira work active, present. Semakula Ryan inactive.
Present, sir.
Inactive. Sorry. Come. Yes. Come on the next class. I will mark you present on the next class. Okay.
Why today
You are
not, sir? I've been present, sir.
No.
Yes.
Okay. Have a nice day, Ryan.
Sir.
Okay. Have a nice day. You were absent today. Okay.
I've
No
been
matter.
present.
You come right now only. Okay. And you come
Not
here
right now.
only for last 10 minutes and you are saying that I'm present.
Sir,
Okay.
not 10 minutes.
See, okay, not 10 minutes, maybe one hour, but you didn't write any answer today. I asked nearly 30 to 40 questions today. You didn't write any single answer. So how I can make you mark you present? Tell me.
Like I
Okay.
didn't write an answer because I have
Your
some
mental present is
issues.
important, Brian. Your mental present is important, not physical present. All right. So he's absent. Then just a minute. And Kaisun is also absent. Sekhar present. Dereje present. David present.
Yes.
Eba present. Nahum, I think Nahum present. Gloria present. Hayamanath present. Isaac Isiko absent. Arafat present. That's all. So I can identify who was active person and who was inactive. I can mark you present. So the